Hello guys, welcome to another session of special topic which is machine learning. In this session we will talk about machine learning, how it works and what are the types of machine learning. We will see in detail their types and their uses in different domains. So today's agenda is how does machine learning work. What are the types of machine learning? In these types, we will talk about supervised machine learning, unsupervised learning, reinforcement learning. These are the three basic machine learning types, and we will discuss in detail how these types are different, how they work, and what are their examples, how they are implemented in different domains in medical, healthcare, in banking, in retail, and in other domains. We will discuss this in detail in this session. So, what do you think? How does machine learning works? Okay, let me tell you. Well, machine learning is subset of artificial intelligence that focuses mainly on the design of systems that can learn from and make decisions and predictions based on some experience, which is data in case of machines. So, machine learning enable computers to act and make data-driven decisions rather than being explicitly programmed to carry out a certain task. These programs are designed to learn and improve over time when exposed to new data. Let's see in general how a machine learning works. One of the approach is where the machine learning algorithm is trained using a label or unlabeled data set to produce a model. So there are two data sets, two types of data sets. One is the labeled one and one is the unlabeled one. What does labeled one means? Labeled one means, for example, if you have a data set of fruits, so if there is an apple, you will place a label on it that okay, this is an apple. If there is a mango, you will place a label with it that okay, this is mango, so that you can differentiate. So this is the labeled data. You are also telling what type, from which class this product belongs, or from which what type of fruit it is. So new input data is actually introduced to machine learning algorithm, and it make prediction based on the model. So you can see here actually in this diagram that first there is a training data. What is the training data? Training data is the data which you are providing to the machine. It might be the labeled one, it might be unlabeled one. As I told you, labeled one has the labels with it, and the unlabeled ones are the ones with no label with it. So you are not telling the machine that is it an apple or is it a banana or a mango. These are the unlabeled one where you are not telling the machine which fruit is it. You are just giving the pictures of the fruit. In the same way, you might be giving a text to the machine. So, but you are not telling that what type of text is it if you are classifying the text, I mean. So these are the unlabeled examples. So you are giving the data to the machine, and then you make the data into an appropriate form, and that data will be the most useful in the most useful representable form, so that machine can understand the data. And after that, you start training the algorithm, and once the algorithm is being trained on the training data, it is then also, if it sees that okay, if my training is not accurate, then it goes back and it says, oh, you did not train well, my prediction is wrong. So it then again starts training. I mean, it enhances its performance. So then after that, once the training is complete, you give a new data, unseen data, which is not seen by the model. You give that data to the machine, and then machine predicts that whether what type of it is. I mean, if you are classifying the fruits, then it will tell you which fruit is it. If you are classifying the documents, or if you are identifying some disease, then the machine learning will predict based on its training. So the new data is introduced to the machine learning algorithm, and it make prediction based on the model. The prediction is evaluated for the accuracy, and if the accuracy is acceptable, the machine learning is deployed. So once you are training, the machine learning checks its prediction in the training data also. Okay, whether because you are giving the data, you are also giving the labels to the machine. So once the machine is predicting, it also cross checks with your labels. Okay, I predicted right. Okay, the accuracy is good then. Then if on the other next sample, if it predicts wrong, then it will match with your label. Okay, the actual label was different. So it means I predicted wrong. In this way, it will enhance its performance, and the prediction is evaluated for the accuracy, and if the accuracy is acceptable, the machine learning is deployed. Now if the accuracy is not, then what will happen? If the accuracy is obviously not acceptable, then the machine learning algorithm is trained again and again with an augmented training dataset. This is just a high level example shown in this figure, as there are many more other factors and other steps involved in it. So this is just a basic general diagram of how machine learning works. So I hope now that you understand that how the machine learning works. Machine learning works in a way that you fed the data, you also give the label if it is labeled one. If it knows, then obviously you are not giving the labels. So actually, what is the label? Instance or sample? For example, an instance and sample is actually once, for example, there are different pictures of the fruit, okay, and you are giving that pictures to the machine learning so that it can learn and then it can predict. So if you are giving one picture, that is the one sample. Hmm. Then the next picture is another sample or another instance. So these are the samples, and the labels are, for example, if you are giving the picture of an apple, you are also telling the machine learning algorithm that this is the picture of an apple. So apple is the label. In the same way, if you are doing the face classification or recognition, in which you are giving the pictures of different people to the machine learning algorithm so that algorithm can learn and then later it can predict. So if you are giving a picture to the algorithm, that is a sample or instance. Okay, one instance, one sample. And you are also telling, okay, this picture belongs to Ahmad. So that is the label. So this is the difference. And label, you can also say that a class. Okay, for example, you all are in one class. Which class? Your class is special topic. Okay. So special topic is the label and every one of you is like an instance. In the same way, there might be a word used later on in the lectures called attribute. Okay. What is the attribute? Attribute is like, you can say that you are classifying a diabetic patient. Okay. Whether you are giving some medical reports to the machine learning algorithm, and then based on that input the algorithm will predict whether the patient has diabetes or not. So in that you will give different type of data to the uh, algorithm, to the model. So in that data belongs to one patient. Okay. So it's a one instance. In that instance, that data might be the blood pressure you are also giving. You are also giving the for example weight of that patient. You are also giving the height of that patient. uh, you are also giving what else, some other blood test of that patient. Okay, you are giving it at the same instant to the machine. So all this is the one sample. All these values is one sample because it belongs to one patient and it is from one test. So but each thing, each content in it, each value is an attribute, you can say. For example, blood pressure is an attribute of that sample. In the same way, weight of the patient is an attribute, height of the patient is an attribute, and some other blood tests, those are also the attributes of that sample. So there are three things in that. One is the sample or instance, another is the attribute, and the third one is the label or class. Okay, so I hope now that you have understand how the machine learning works in the general overview. I mean, so let's see now the types of machine learning. There is not a specific type of machine learning. Machine learning is categorized actually into several subcategories. Now let's move on and see subcategories of machine learning, which is actually categorized into three different types. So those three types are, you can say, supervised machine learning, unsupervised machine learning, and reinforcement learning. Let's see what each of these are, how they work, and how they are used in the field of banking, healthcare, retail, business, and other domains. And obviously, don't worry, I will make sure that I use enough examples and implementation of all three of those to give you a proper understanding of it, obviously. And in the coming lectures, I will also implement these. I will show you the code of Python, how we can implement some examples of these algorithms. Okay, so the first one is the supervised machine learning. Supervised machine learning is actually a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. So let's see a mathematical definition of supervised learning. Supervised learning is where you have input variable x and an output variable y. Obviously, the input variable is the, you can say it, instance, and the output variable are the labels. And we use an algorithm to learn the mapping function from the input to the output. That is obviously y equals to fx. So we are training the algorithm so that algorithm can come up with some function so that it can match x onto y. So the goal is to approximate the mapping function so well that whenever we have a new input data x, we can predict the output variable y. So what actually machine learning is doing, you are giving the data, you are feeding the pictures, might be you are feeding some text data, might be you are giving some sound data or signals. So what, and we are also telling the labels in that, in supervised machine learning, and which is obviously the y. So what does machine do, model do? It actually tries to figure out some connections, you can say, so that it can label, it can, I mean, match each x to some y. So it has to find that function. So let's simplify it by rephrasing the mathematical definition as I told you before, as a machine learning method where each instance of training dataset is composed of different input attributes and an expected output. The input attributes of the training dataset can be of any kind of data. It can be a pixel of the image, it can be a value of database row, or it can be an audio frequency histogram. So as I told you, the input attributes of the training data can be anything. If you are giving the text, that text have many attributes, like in case of the diabetic patient, I was telling you that attribute might be the height, the weight, okay, the blood pressure. So these kind of things are different attributes, and that is the textual data. In the same way, if you are giving an image, image is what? One instance, one sample. In that sample, there are different attributes, and those attributes might be the pixels of that image, and in an image there are hundreds or thousands of pixels. So each pixel is an attribute. So for each input instance, an expected output values are associated. Okay, as I told you that each input has an output, obviously it belongs to some y value. So those are associated with each other. These values can be discrete one representing a category, or can be a real or continuous values. And you know obviously what discrete means. Discrete means the exact value, but continuous might be the weather. In the weather case, if you are predicting a weather, what will be the weather tomorrow? So the weather is a continuous thing. In the same way, if you are predicting the stock exchange value, future stock exchange value, that is also a continuous value. Or you are predicting what will be the price of the houses in, you can say, Istanbul. So that is also a continuous value. In both of the cases, whether it is discrete or continuous, the algorithm learns the input pattern that generates the expected output. So the machine learning algorithm tries to learn and find the pattern which can match the input to an output. Now once the algorithm is trained, it can be used to predict the correct output of a never seen input. You can see an image on your screen in this slide. In this image, we can see that we are feeding a raw input image, okay, of an apple to the algorithm. You can see here there are different apples, and we are feeding it to the system, to the model, machine learning model, and then the model tries to train itself on that data. On the other hand, as a part of algorithm, we have a supervisor who keeps on correcting the machine or who keeps on training the machine. So what actually you can see here in this slide, there is a teacher who is telling to the student that, okay, if you are making a mistake, okay, hold on, you made a mistake here, please correct it. Okay, so the teacher is supervising it. So that's why it is called the supervised learning, because there is a supervisor. Okay? And that supervisor is actually telling the machine, oh, hold on, you predicted the wrong, you are not training well, because you expected output should be apple, but you are not making the prediction as an apple, so your prediction is wrong. Okay, so the supervisor is keep checking if it is desired output is not according to what obtained, then obviously it will train the algorithm again. Okay, it keeps on telling that yes, it is an apple. If there is an apple and the machine algorithm, I mean, predict it right, that yeah, okay, it is an apple, then supervisor says, ah, yeah, okay, you are right, keep going. Okay. But if it is not an apple, it tells the machine that it is not an apple, and things like that. I mean, if it is belongs to you are training with another data, then obviously the supervisor will uh, tell to the machine according to that labels. So this process keeps on repeating itself, okay, doing different iterations again and again and again until we get a final trained model. Okay. Once the model is ready, obviously, it can be easily predict the correct output of never unseen data. You can see here in this picture that we are feeding the images of the apple to the algorithm, and the supervisor is supervising. If the algorithm makes a mistake, the supervisor corrects it so that next time the learning algorithm don't repeat the same mistake. So once it achieves the high accuracy on the training data, okay, then the model stops because it has attained the highest accuracy on the training data. Okay. Once the model is fully trained, then what you are doing, you are giving another data set. Okay. And then you are giving to that machine so that machine can predict. And that data obviously would have never been given before. Okay. So as you can see here that this apple, green apple, is never fed to the system before. So now we will test it with the new data because this apple has a new color. Okay, a color that the model has never seen before. Okay, and it has also a leaf on it. So now we are really testing hard that whether the trained model will perform right or not. So we are giving an image of a green apple to the trained model, and now the model can now easily identify it as yes, it is an apple. So Thus we can see that it predicts correctly. So let's make things more clearer with another example of supervised machine learning. So in this slide, uh, the image shows an example of supervised learning process used to produce a model which is capable of recognizing the ducks in the image. The training data set is composed of labeled pictures of ducks and non-ducks. Okay. So now we have two type of labels. One is the duck, and another label is not duck. Okay. There can be more than labels, two type of labels. Okay. There can be duck, there can be Mickey Mouse, there can be another. Okay. So it's just an example. So in this example we have two type of labels. One is the duck one, another label is not duck. Not duck means anything else other than the duck. So the training data is actually fed to the algorithm, and algorithm is trained on that training data on these pictures. The result of supervised learning model is a predictive model which is capable of associating a labeled duck or not duck to the new images presented to the model. So now once the model is trained, the resulting predictive model can be deployed to the production environment. So once you have trained the model, you can deploy it. Just take out that model and fit it onto your machine so that you can now predict on the unseen data. You can deploy it on your mobile phone also, for example. Once your model is ready, you can deploy it on your mobile phone, so it is ready to recognize the new pictures right away. You can just take a picture, fed it to that application, and then that application will recognize whether it is a duck or it is not a duck. Okay. So now you might be wondering why this category of machine learning is named as supervised learning. Well, it is a supervised learning because the process of an algorithm learning from the training dataset can be considered as teacher supervising the learning process. As I told you in the previous slide, that you can consider it that there is a teacher who is supervising that learning process. So we know the correct answers the algorithm iteratively makes while predicting on the training data. So the algorithm knows what are the correct labels. So if the algorithm is not predicting it correctly, it will start training again. Iteratively makes while predicting on the training data. And obviously if it makes a wrong decision, wrong prediction, then it is corrected by the teacher. The learning process stops when the algorithm achieves an acceptable level of performance. So once the model is trained, then you can give a new picture here. At the bottom of this slide you can see we are giving a new picture of the duck to the predictive model, and then the model predicts that, oh yes, it is a duck. So now let's move on and see some of the popular supervised learning algorithms. So in the supervised learning algorithm, we have linear regression, logistic regression, random forest, decision trees, naive-Bayes classifier, sport vector machine. These are just for your information, by the way. We will discuss all of these algorithms in our coming session. So you just have to remember that okay, these algorithms belongs to the supervised learning type. Now let's see some of the popular use cases of supervised learning. So we have Cortana or any other speech automation in our mobile phone is trained using a voice, and once trained it starts working based on that training. This is an example of supervised learning. For example, suppose you are telling, okay Google, call Murat, or you say, hi Siri, call Muhammad. So once you are saying that, you get an answer to it from that automated machine, and an action is performed, and it automatically start calling to Murat. If you have said call Murat, or if you have said call Muhammad, it will start calling Muhammad right away. So this is one of the examples of supervised learning. Another example is the weather application based on some of the prior knowledge, like when it is sunny, the temperature is high, or when it is cloudy, humidity is higher. Any kind of that, these applications predict the parameters for a given time. So this is an example of supervised learning, as we are feeding the data to the machine, and also we are telling that whenever it is sunny, the temperature would be higher. Whenever it is cloudy, the humidity should be higher. So we are also labeling the data, and we are training it obviously. So next time once the model is trained, it can predict. So these supervised learning algorithms are also best in using in predicting the weather. Another example is the biometric attendance, where we train the model, and after a couple of inputs of our biometric identity, that can be our thumb or iris or yellow or any other thing. Once that model is trained, it can validate our future input and can identify uh, based on our thumb impression or based on our iris or whatever that input data was. So next comes in the field of banking sector. In banking sector, supervised learning is used actually to predict the credit worthiness of a credit card holder by building a machine learning model obviously, to look for faulty attributes by providing it with the data on delinquent and non-delinquent customers. Okay, so these machine learning algorithms are also being used in many different ways in banking sector. It is whether detecting that okay, is any faulty transaction made or not. So in the health sector also, the supervised machine learnings are very popular. For example, in the health sector, it is used to predict the patient's readmission rate by building a regression model by providing data on patient's treatment administration and readmission to show variable that best correlates with readmission. So there is another example of the sector. In the retail sector, it is used to analyze the product that a customer buy together. It does this by building a supervised model to identify frequent item sets and association rules from the transactional data. so that if the customer is buying this product, it also sometimes shows that okay, you should also buy this product together because many people are buying these together. So here there they are using the machine learning algorithm. Now let's learn about next category of machine learning algorithm, and that is the unsupervised machine learning. Mathematically, in unsupervised learning is where you only have input data x and no corresponding output. So it means there is no teacher, supervisor. There is no supervisor who will tell either you are making a mistake or not. Okay. And so here what you are doing, you are just giving the data. That's it. You are not providing the labels. This is why it's called unsupervised learning. The goal for unsupervised learning is to model the underlying structure or the distribution in the data in order to learn more about the data. So let me rephrase it into simple terms. In supervised learning approach, the data instances of a training dataset do not have an expected output associated to them. Instead, unsupervised learning algorithm detects pattern based on innate characteristics of the input data. Okay. So what in unsupervised learning model are doing, they are actually trying to find out the pattern based on their innate characteristics because there is no label provided. So as an example of machine learning tasks that applies supervised learning is clustering. What is clustering is actually is you are grouping same kind of you can say data or same kind of how can I say samples to one group, and then another kind of data, another kind of samples to another group. For example, here you can see that there are four different types of kind of fruits: apple, banana, mango in Turkish mango, but in English mango, and oranges. So now you are not telling the machine that okay, these the red ones are the apples. You are not telling it. You are just giving the data to the machine. You are also giving the data of the banana pictures of the banana also, but you are not telling the machine that okay, this is the banana. And in the same way, you are not telling this is the these are the mangoes, these are the oranges. So you are just feeding the data. So now what machine learning will do? Machine learning will say, okay, this I'm just telling you in a layman wording. Okay, these are the red ones and these have this kind of shape. So they are almost similar. It means they are one kind of thing. So machine learning segregates them, define them as one kind of product, you can say, or item. So it groups them. Okay. For example, I'm giving you an example of in our daily life. For example, if you have to uh, if you are measuring the height of a student and then on based on that you are making the groups, so you have already you are saying okay, he looks like 160, between 150 and 160. Okay, you can go to group A. He looks he's in between 160 and 165, so he can go to group B. So in the similar way they are just judging based on their characteristics of the input data. So in this task, similar data instances are grouped together in order to identify clusters of data. As you can see here in this slide, the, we have different variables of fruits as input. Now these set of fruits are given obviously as an input x to the model. Now once the model is trained using unsupervised learning algorithm, the model will create clusters based on its training, and it will group the similar fruits and make their clusters. You can say in the normal terms, you can say cluster is like a grouping. You are grouping similar kind of items together. So if don't worry if these did not make it clear to you, let's move on and see another example so that the things get more clearer about unsupervised learning. So in this slide, the image shows an example of unsupervised learning process. This algorithm processes an unlabeled training dataset, and based on the characteristics, it groups the pictures into, you can say, two different clusters of data. For example, in the supervised one, we were also telling the machine that okay, these are the ducks and these are not ducks. But here you can see we are just giving the images. We are not telling the machine whether it is a duck or it is not a duck. So machine is judging based on their characteristics. Okay, that characteristics might be some color or might be some shape or something else. So based on those characteristics, machine, this unsupervised learning algorithm, try to group the similar items into the one group and other same kind of similar items into another group. So here the unsupervised learning algorithm segregated these six images into two groups. Despite the ability of grouping similar data into clusters, the algorithm is not capable to add the labels to the group. The algorithm only knows which data instances are similar, but it cannot identify the meaning of this group. So now you might be wondering obviously why this category of machine learning is named as unsupervised learning. Well, actually, these are called as unsupervised learning because unlike supervised, these are called actually unsupervised learning because uh, unlike supervised learning, there is no correct answer and there is obviously no teacher. So that's why it is called unsupervised learning. So algorithms are left on their own to discover and present the interesting structure in the data. So I hope now you have understood and you can differentiate what does unsupervised mean and what does supervised mean. So let's move on and see some of the popular unsupervised learning algorithms. So we have k-mean algorithm, a priori algorithm, and hierarchical clustering. Obviously, these are just for your information, and in the coming lectures, we will try to implement at least one of these in Python. Now, let's move on and see some of the examples and use cases of unsupervised learning in different kind of domains: health sector, banking, retail. So, before we start and discussing about those domains where these unsupervised learning algorithms are being applied. Let's suppose a friend invites you to his party and where you met strangers. And obviously, when you are meeting a stranger, you don't know them, you don't know their name. Now, you will be classifying them using unsupervised learning as you don't have any prior knowledge, you don't know who they are, from where they belong. So, this classification can be done on the basis of gender, age, group, how they are dressing, their education, how they are behaving. Obviously, their qualification might be when they are talking, you are judging them, okay, how they are. You are classifying those strangers based on that, your interaction with them. Okay. And whatever way you might like, you can classify them according to what you are learning from them. Now, why this learning is different than supervised learning? Since you did not use any past or prior knowledge about the people, you kept on classifying them on the go. As they kept on coming, you keep classifying them. If more people are coming, you are classifying them based on your interaction, based on what characteristics you are learning about them. Okay. Yeah, this category of people belong to this group, and that category of people belong to that group, and this one's he belongs to this kind of people, to this kind of group. If he's behaving well, you will say, he's a nice person, he is good, this and that. And if someone is acting rudely or something, or he is not eating in a good manner, you will say, he is like this, he is not good. So you are classifying them based on their characteristics you are observing. So before we go, suppose you have never seen a football match, even though it's impossible. I mean, Turkish people and most of the people in the world, they are crazy about football. But suppose you have never seen a football match before, and by chance you watch a video on the internet. Now you can easily classify the player on the basis of different criteria. Like if the player is wearing the same kind of jersey, it means it belongs to one class, and that class is obviously the team name. So, but you don't know what the team names are because you are watching it for the first time and you don't know that, oh, there are teams. So you are watching and you're saying, he is wearing the red shirt, and the other person, other player is also wearing the red shirt. So it means they belong to the same class. Okay. So you are actually observing their characteristics, their similarities between them. So if the player is wearing another kind of jersey, obviously then he belongs to another class. Or you can also classify them on the basis of their playing style. For example, you can see, this player is an attacker, and then another player is also attacking. So they belong to one type of class. They are the attacker players. So you are imagining and you are classifying them based on what you are learning. So now let's move on and see unsupervised learning used in different sectors, banking, healthcare, and retail sectors. First, let's start with the banking sector. In banking sector, it is used to segment customers by behavioral characteristics via surveying prospects and customers to develop multiple segments using clustering. In the same way, in healthcare sector, it is used to categorize the MRI data, or you can say the X-ray data or CT scan image by whether it is a normal one or it is an abnormal one. Okay, if there is some abnormality in that image, you can say that okay, the patient has something, some disease he has, because these images are not similar. Obviously, normal people have almost the same images, but abnormal ones they might have different ones. So the machine will observe, these are the clearer images, so they belongs to one type, and that type obviously would be the you can say the normal ones. And if there are some dots or something in that images, some tumor or some other thing, it will say they are abnormal ones. So it uses deep learning techniques to develop a model that learns from different features of images to recognize a different pattern. And I suppose that you already know what is the difference between deep learning and machine learning. Similarly, in addition to this, in retail sector, it is used to recommend products to the customers based on their past purchases. It does this by building a collaborative filtering model based on the past purchases by those customers. So I suppose that you guys now have a proper idea of what unsupervised learning means. If you have any doubt, please don't hesitate to ask me. And you know my email address. You can send me an email anytime. It's jawadrashid at gmail.com, or you can also send me on my university email account also. So let's discuss the third type of machine learning, and that third type is the reinforcement learning. So can you tell me what you can imagine from this picture? What you are imagining from by seeing this picture? Just as a hint, as a clue, I am giving, like, for example, he has in his mind that, okay, if I will clean, I will get the money. So actually, you have made his mind like this, that okay, if you will clean, give, you will be given a reward. Okay. So he thinks that if I will clean the stuff, then I will be rewarded by money. So what is the reinforcement learning here? Is the reward. You are reinforcing. Clean, you will be rewarded. If you will not clean, you will be penalized. So reinforcement learning is a type of machine learning algorithm which allows software agents and machines to automatically determine the ideal behavior within a specific context to minimize its performance. So this is actually the definition of the reinforcement learning. If you couldn't understand, let's move on and discuss what it is. So the reinforcement learning is about interaction between two elements. Okay. And that element is the environment and the learning agent. The learning agent, I will discuss this picture later on. The learning agent leverages to actually uh, mechanism based on two things. One is the exploration and the other is exploitation. When learning agent acts on trail uh, and acts on trial and error basis, it is termed as exploration. But when agent acts based on the knowledge gained from the environment, it is referred as exploitation. Okay. So when the agent learns on the from you can say from the knowledge gained from the environment, then it is referred to the exploitation. So now, obviously, this environment rewards the agent for correct actions, which is reinforcement signal. Leveraging the rewards obtained, the agent improves its environment knowledge to select the next action. Here you can see that there is a loop, a circle. Okay, in that the model is being trained. Okay. You are giving the raw input without whether it is mango or not. It does not know yet. Okay, so you are giving it. and there is an environment, and from that environment it is being reinforced. Okay, selection of the algorithm, and then it goes back. If the action is the best action or not, then it gives the reward. Okay, so let's discuss this slide. We can see that the machine is confused whether it is mango or not a mango. So then what? Then the machine is trained using reinforcement learning. If it makes correct decision, it gets reward point for it, and in case of wrong, it get a penalty for that. Okay, so once it shows the environment, then if the decision is not correct, it gets the penalty. And here reward is also, you can say, replaced by penalty. If there is no reward, it means there is a penalty for it. So obviously when the agent gets reward, it means he made the correct decision, and it means he is going in the right direction. So the training is right. If there is a penalty, then obviously it thinks again, I made a mistake, I am penalized, so I have to correct myself. So in this way it learns. Once the training is completed, now the model can easily identify which one of those is mangoes. So, and obviously once the model is trained, you are giving another input, an unseen input data. You are inputting an unseen data, and the model will predict based on its training whether it is a mango or not. If it's different kind of data, obviously then it has to predict according to that. So let's see another example here. In this slide, we can see an agent whose job is to find out which of these two is the Mickey Mouse by judging the environment, obviously. So the first task the agent has to perform is to observe the environment. He will observe, okay, what's going on. Next, he selects some action using some policy. Obviously, you have defined some policy so that he can model has defined some policy so that he can make some decision on that. So the machine has to decide which one of those is the Mickey Mouse. There is a picture on the left side is the Mickey Mouse, on the right side this is the duck. So in the reinforcement, the machine first observes the environment and then it will select some action based on the defined policies. Then what the machine will do, uh, uh, based on the defined policies, he will decide, okay, the action is the decision. So he decided, this one is the Mickey Mouse, the one on the right side. Oh, wait, oops, this is the wrong answer. So there is a penalty for it, minus 50 points. So it seems that the agent has made a wrong decision by choosing a duck as a Mickey Mouse. Uh, Therefore, the agent, or you can say the model here, agent or model, you can say replace it, but will be penalized with the minus 50 point. And so the first one is the observing the environment. Second, he has to select an action based on the policy. He selected the action, and the action is the decision, and then there is a reward or penalty on that. So the next is, once it gets a penalty, what is next? As the machine has wrongly identified, so it's time to update its policy. So it knows that, oh, I made a mistake, so I have to update the policy. The process of judging and updating will continue till the model gets an optimal policy. Okay. Optimal policy is where the accuracy is the maximum. Okay. So for the next time, the model will know that this is not a duck. Uh, this is, duck is not a Mickey Mouse. So the fifth one is update policy. It's a learning step. Okay, the model is updating its policy. It's learning that I made a wrong decision. I said that duck is a Mickey Mouse, so it's wrong. So I have to update my policy. Okay, so I have to update my learning step. I should learn more hard, okay, so that I can identify properly. So it iterates again to get the optimal policy, to update its policy again. It iterates again and again, and these steps are repeated until it gets the optimal policy. So before we go and discuss the use cases of reinforcement learning, let's see how Pavlov trained the dog using reinforcement learning, or how he applied the reinforcement method to train his dog. Okay. So in this slide you are seeing that dogs training with reinforcement learning. Pavlov integrated learning in 4 steps. You are seeing these 4 steps here in this figure. Initially, he gave a meat to his dog, and in response to the meat offer, the dog started salivating. In this next step, uh, what he did actually is, you can see here that he rang a bell. Okay. For this, the dog did not respond anything, as the dog don't know the meaning of ringing the bell, because he has never seen that bell, and he did not respond on that. So there is no salivation by the dog, no conditional response, because it's, you can say that, neutral stimulus. And in the first one is the unconditional stimulus. You did not have put any condition on it. You are just giving the food. In the second one, you are giving the neutral stimulus. You are giving a condition, but there is no condition actually, because there is no meat, and you don't understand what the bell means. So what he did in the third step, he tried to condition the dog by using the bell and then giving him the food. So first he rang the bell and then he gave the food. Then the dog understand. After seeing the food, the dog started salivating. So eventually, in the last step, in this situation, there comes a situation when the dog started salivating just after hearing the bell, even if the food was not given to him, because the dog was being trained like this, that whenever there is a ring, it means the food is coming. So he started salivating, even though there is no food. He didn't give him any food, but still he was salivating, as the dog was reinforced to do that. Whenever the master rings the bell, the dog will get the food. So I hope you understand what reinforcement learning is. Now let's move on and see how reinforcement learning is applied in the field of banking, healthcare, and retail, and some other sectors. So starting with the banking sector, in banking sector, reinforcement learning is used to create the next best offer model for a call center. This is done by building a predictive model that learns over time as user accepts or rejects offer made by the sales staff. So this is one of the examples where reinforcement can be applied. Similarly, in healthcare sector, reinforcement learning is applied to allocate the scarce medical resources to handle various type of ER cases, uh, such as we can build a Markov decision process that can learn treatment strategies for each type of ER case. Uh, in the retail sector, reinforcement learning is also applied in different kind of problems. For example, reinforcement learning can be used to reduce the excess stock with dynamic pricing by building a dynamic price model, obviously, that adjusts the price based on customer response to the offer. So I hope now you have attained some understanding of what is machine learning, how machine learning works, the journal overflow, and an overall general view of the machine learning and different types of machine learning and how they are being used in different kind of problems in various domains. Uh, if you have any questions, you can ask me or you can email me on jawadrashid@gmail.com. Okay, guys, see you in next session.